Hi everyone, my name is Santiago Nino and with my group Nicolas Polignan and Gabriel Santos, we are to present the UAVs. What is a UAV? The UAV is a unmanned aerial vehicle. That means that it's no pilot, and the pilot it can fly on the ground and is flown by a self-programming flight path or a dynamic systems. Now, a little history for the origins of the UAVs. The first recorded were in 1849 by the Austrians that they take a balloon with a basket and they put the bombs inside, and they have a time mechanism that open the bottom of the basket and drop the bombs into the city of the east. That balloons were used as well on the US Civil War in 1860, and in 1883 Douglas Archibald used a kite and a camera in order to take pictures for the air. An American soldier watched that and rapidly adopted to the army, and they put it as well bombs to drop it to the enemies. During the World War I, René Laurie in 1970, he created the gyroscope and barometric stabilization. In 1918, Charles Kettering was ordered to create an aerial torpedo. What does that mean? They created the Kettering book, that is when he is flying, an automatic control, drop up the engines and drop the wings, and automatically the torpedo goes to the enemies. The World War II in 1942, the Interstate BQ-4 was developed by US, and they fly by only 2 pistons engines and was remotely controlled and flying 2,000 pounds of bombs. As well, in 1944, the Germans invented the Fizzler F103B1, and it has a speed velocity of 400 miles per hour. Another 2 models was created by the Germans as well, and they are launching for a mid-out controlled model plane. Between the period of 1950 and 1970, a lot of new UAVs were coming. One of that was the AMQ-34 Ryan Firebee series, that is, for that picture, really effective on surveillance and stealth missions, and they put it covered with anti-radar blankets and paint in order to avoid hit detection. The Lot D-21 was landed for a Boeing, and they have the fastest UAV in history, and the max speed was 2,210 miles per hour. Another foreign model was the Ryan 147, that was the first UAV pilot from the ground, from a cabin, like this picture, and he carried TV cameras and laser designator, was developed in 1970s. One newer was the 1986, the Pioneer. He was made for carbon fiber, fiberglass, aluminium, balsa wood, and copper. He used for a civilian mission, and it could be self-flying or probably controlled by a pilot in the ground. And in 1990s, the Dark Star was developed by Lockheed Martin and for the Boeing, and it was described for a clamshell with wings for the model. They fly about 40,000 miles and take close pictures for a soldier for the ground, really close. And now I introduce Nicolas. He explained now the present of the UAVs.
Hi, my name is Nicholas, and I will talk about the present of the UAVs. Since there was an increase in technology, nanochips, and microcontrollers, UAVs are not only used for military purposes, but also for civil. Some of the civil applications include recreational photography, videos, research as a farming tool, structural inspectors, disaster tools, supply carriers, and scouting. Also, militaries now qualify UAVs into 4 different categories: target and decoy, reconnaissance, combat, and logistics. Researchers have actually used UAVs such as this one and incorporated with some sensors like biological, gamma rays, infrared, ultraviolet, temperature, pressure, and wind speed. With these kind of sensors, they can go into the field and actually take these measurements without having to put themselves in danger. Such as gamma rays can be dangerous to humans, but if you send a UAV, you can get the same measurements without having to put your life at risk. Also, the NOAA, National Oceanic Atmospheric Administration, uses AUVs to control wildlife migrations, or they can actually go into the field and control vegetation and check on them without actually having to scale hundreds and hundreds of miles. Farmers also use UAVs to survey crops and livestock without actually having to go out. They can just send out UAV and see how their crops are growing. UAVs such as this one, which is called a U.S. Coast Guard Bell Eagle Eye Tilt Rotor, can be used in case of emergencies. This one's called tilt rotor because its nacelles can be turned at 90 degrees once it's in the air, and at the same time take off vertically. This one's actually used for surveillance and reconnaissance during emergencies for the Coast Guard. As a disaster, it can go into places where if humans cannot reach due to the obstruction of different materials, they can go carry supplies, they can scout areas and see what is the best way to get there, and also pinpoint strategic entrances. Civilians have also used UAVs to take recreational videos such as, or pictures such as this one, or even of monuments and mountains that would be harder to reach, but with UAVs you can climb different altitudes and reach the pictures that you wish. Also, UAVs such as the CANCON, the yellow one up there, it shows they use them for power line inspections and to see if there's anything broken, and without having to send a human up there, which could be dangerous due to the height and also the electricity. Like I stated before, military have developed different UAVs and have categorized them into 4 different categories. One of them is called target and decoy. Targets and decoys are used as an aerial gunnery against enemy, as shown in the first picture. Another category is called reconnaissance. Reconnaissance is used to survey unknown territory, gather intel on enemy position and hideouts, prepare key engine plans. With UAVs such as the Shadow 200, Marines and Army can fly day and night up to altitudes of 8,000 feet and get real-time data on where the enemy is located, where the hideouts are, and what is the best way to go into war. Another category is combat. These UAVs are specialized for missions that require heavy artillery to take down either enemy base camps or vehicles. One of the examples is called the Predator. The Predator is highly known for using the Hellfire missiles in Afghanistan. Finally, the last category is called logistics. Logistics is similar to the U.S. Coast Guard one, but their main purpose is to carry supplies behind enemy lines. And the reason why you use a UAV over regular helicopters is because if a helicopter gets shut down, then you lose 2 lives. In this case, a UAV is only a piece of machinery, even though it costs a lot of money. And now, Gabriel Santos is going to present the future of UAVs.
Hello everyone, my name is Gabriel Santos and I'm going to be talking about the future of UAV. UAVs have taken a huge step into the future in terms of their technology and applications. We now have better sensors and better technology. As my team member Nico explained, we have all these different types of sensors such as electromagnetic, gamma rays, better GPAs, biological sensors, and even chemical sensors. One of the most groundbreaking technologies is the ability to increase UAVs autonomy. This will allow UAVs to make their own decisions without human intervention. In other words, we will take the UAVs where to go but not how to get there. They will make that decision on their own based on their surroundings. DARPA is one of the agencies that has been working on this. They're developing new and very small, tiny UAVs that are capable of flying up to 45 miles per hour with very high precision. Thanks to all these new technologies, UAVs have made their way into a lot of different fields. For example, into police missions. The FBI was one of the first departments to get the Federal Aviation Administration approval for use of drones. Another field is agriculture. With better sensors, now we have something called precision agriculture. Another field is the one of meteorology, where UAVs have been proven very helpful for the weather analysis and even storm chasing, where human intervention could be very dangerous. News gathering is another field. CNS has already made a treaty and an agreement with FAA for the use of drones. This can also be very helpful for recording massive events such as a sport event. Another very important field is the one of surveillance. UAVs are being proven to be very efficient assets for border patrolling and for gathering data and informing officers after an accident has happened. A more fun field is the one of carriers and deliveries. Many companies are using UAVs such as Amazon and Google, with other companies following their footsteps. There's a very famous UAV right now called the Tachocopter that's delivering tacos to their users using just a simple app and a GPS. Another very important field is the one of humanitarian aid. The United Arab Emirates is looking to highlight humanitarian potential by doing a competition every year where engineers will show their developments of how the UAVs can help people. One of their fields is in the medical aid. Here, team of London School of Hygiene and Tropical Medicine are using drones to surveil and patrol geographical zones to gather information about their environment. DHL has been using USBs to deliver medicine as quick and fast as possible to their clients. They call it the parcel option, and it carries medicines of up to over 12 kilometers. Another incredible application is the one of using USBs for detecting landmines, such as the ones in Bosnia. This USB was actually the one who won the competition this year. Another topic is search and rescue, where we have an neutral system, for example, that can control many UAVs at the same time to gather information right after a disaster has happened. We also have communications. Facebook is working on a project called the Connectivity Lab, which pretty much is using solar-powered UAVs in order to transfer and give internet to 2/3 of the entire world. Quarks and Sky Orbiter is a Portuguese company also trying to achieve the same goal: Wi-Fi for everyone through UAVs that use solar cells in order to power themselves. That we might one day expect them to sustain flight for up to years. Nevertheless, there are some barriers that are stopping UAVs to reach their fullest potential. There still exists some skepticism towards autonomous systems and their safety and reliability. Also, the FAA has a lot of regulations, and with good reason. With so many companies creating and manufacturing more and more UAVs, now we have different sizes, different specifications that make the fact of controlling all of them a lot harder. The most lucrative and important field for UAVs is definitely the military. Here are some future models to look up for in the future. We have the MQ-4C Triton for the US. It's a Northrop Grumman manufacturer, and its main goal is ISR and search and rescue mission. It has a 360 degrees camera that allows him to make the best autonomous decisions possible. Here's some pictures, and we're expecting it to be completed by 2017. The ATCOM System United 40, it's a middle-altitude long-endurance UAV. Its main objective is real-time combat and damage assessment, recognition operations, border surveillance, and humanitarian aid. One of the most characteristic properties of this vessel is their serpent-like type of body design. The BIA system Taranis, it's manufactured in the UK. It's expected to be completed by 2018, and it's a combat air vehicle. It weighs 8 tons and it's called Tyrannus after the Celtic god of hunger. The Sea Avenger Predator C. This is the third installment of the Predator series. It can sustain up to 20 hours of flight and it's going to be completed by this year. Here's some more pictures of the Predator C. Arca Air Strato. This is an electrical power aircraft. It can have an altitude 2 times bigger than commercial airlines, and it's powered by a satellite and a GSM. There are 2 types of models, an Explorer and a Pioneer, and these are actually commercialized. So it's closing the gap between what's very expensive and very big UAVs. Here are some more pictures, and they work on solar power. The last one and my favorite one is the Lockheed Azure 72. This is an hypersonic UAV. It's meant for ISR missions and it will carry 2 hypersonic missiles. This is the diagram of the concept of the turbine that it will be using, and that will allow him to reach Mach 6 velocity. That's 6 times the speed of sound. The Lockheed has been with DARPA, which were the ones responsible for the concept vessel of the HTV-2, which actually reached Mach 20 in the test. Now we're going to talk about our own design for UAV. It has a body design similar to the Stealth due to its high aerodynamic performance. It was inspired on the Quensec Zephyr UAV, which is famous for being the one able to sustain the longest amount of time in the air. Our model is going to use 2 engines, a magnetic synchronous motor providing 450 watts. It's going to be made out of carbon fiber, and it will be powered by solar cells, a lithium battery sulfur. Here are some sketches and renderings of their SolidWorks design. We have a top view. This is a front view. Top view from the back, and bottom view. Now, my team member Nico is gonna conclude this presentation.
In conclusion, as seen in this presentation, UAVs have progressed greatly over the years. They have started from a balloon dropping a bomb to these high-end UAVs. Although UAVs have increased in technology, they're still not as smart as, or can respond as smart as a human. They cannot have the same cognitive response as a brain. But I believe that is the future of UAVs. The future of UAVs is having them to respond and act the same way a human would behind a plane. Thank you very much for your